Learning. Well, we've talked about learning indirectly all through the development chapter. Now let's talk about it more formally. We're going to talk about classical conditioning, operant conditioning, and observational learning per se. Three major paradigms that affect every single one of us in this room and have dramatic, pragmatic implications for your life and the life of your family and the life that you live at your work and in your school. If you understand these well, you'll be able to change your own behavior dramatically, and you'll be able to change the behavior of others. And I hope you'll do that benevolently, because you'll be able to do it effectively. People are like, oh, I don't want to manipulate anybody's behavior. And I would say, well, you do that all the time. We all want to manipulate other people's behavior. You don't believe me? The next time somebody asks you to go see a movie that you don't want to see if you don't try to manipulate their behavior. They say, come on, let's go see this movie. And you go, I don't want to see that one. Let's go see this one. What are you trying to do? Change them. Change their inclination. Get them to behave in a way that's more consistent with your own inclination. We all want our way, and we all realize that it helps to get our way when we get along with others and give them their way. And that's our reciprocal determination, right? We try to work cooperatively, so that if you get your way this time, reciprocity would dictate that next time I ought to get my way. But learning in and of itself is much more specific. Relatively durable change in behavior, knowledge due to experience, and those are terms you ought to know. But I'm going to get right on into classical conditioning. Classical conditioning, learning, where a previously neutral stimulus comes to evoke a physiological response originally evoked by another stimulus. That should make no sense to you at this point. Let's do it again. I point those other things out because you should know them. I don't need to tell you every single thing. You have a book, I hope. You're reading in it, I hope. You certainly have my full set of notes, which you are reading, I hope, and that nothing in the previous slide was not definitional, that you should be able to read it and understand the terms I'm using here forward. If not, reread it, and if you have questions, ask me. Ivan Pavlov has an asterisk beside his name because he's famous for working with some dogs, Pavlov's dogs. Well, he worked with other animals besides dogs, and he became famous because he's associated with something. What we're talking about with learning is associations, learning associations. And people learn the association of Pavlov's dogs and a bell. And people sometimes bring me a little wet nap package from Hooters. And on the wet nap package it says, does the name Pavlov ring a bell? Now that's interesting on a couple of levels. One, why would Hooters bother to print that on their wet naps, right? Well, slobbering is what you do when you eat, right? And you need to wipe it up, so maybe there's that association. People slobber at Hooters for other reasons, and maybe there's that association. Male people usually, not always though, right? But interestingly, he's that profound that people know him all these years later. His name is associated with this slobbering dog phenomenon. And if you're a good critical thinker, you should wonder to yourself, well, who cares about slobbering dogs? And I'll show you why in a minute, but it's going to take some backup to get us there. Classical conditioning is something that affects every single person on this planet, including dog people, right? Most people who love the dogs, they call them what? They talk to them like they're people, right? Well, we share a lot with other animals. And classical conditioning is one of those things we share. What you can do to a dog through classical conditioning, you can do to a person if you can make them stand for it. It's powerful. Slobbering dogs has implications for drug addiction, conditioned taste aversions, all kinds of one-trial learning. Things that we just think are totally unrelated to slobbering dogs. Slobbering dogs is not a pleasant thing. He won a Nobel Prize. Ivan Pavlov was not a psychologist. He was a physiologist. He was interested in studying digestion, right? So the digestive tract starts in the mouth and it ends under the tail, right, of the dog. Now, if you have your choice of which end to start on, which end are you going to pick? I'm going to go with Pavlov and start on the mouth first, right? So he starts looking at the first process of digestion, which is salivation. Before you get food in your mouth starts watering. Now, we now know that there are enzymes in the saliva that help to break down the food. But back then, they were just starting to study this, and they would attach a little test tube. They would cut a fistula into the dog's cheek. Not pleasant. Surgical procedure. Attach a catch basin that would then measure as accurately as you could at the time how much saliva was produced when you presented the dog with certain kinds of stimuli, food-related stimuli. All right, so he's looking at how long does the dog go between eating, that it salivates more, does it salivate less, does it salivate more to certain kinds of food stimuli and not others? And something started to go wrong with the research. Dogs started salivating before they ever got there with the food. Starts messing with the measurements. And what was happening was simple on one level, but nobody had really pulled it apart until Pavlov. So he didn't get the Nobel Prize for digestion. He got it for what is now classical conditioning. Give the dog food, the dog salivates. Give the dog food, the dog salivates. Give the dog food, the dog salivates. That dog's salivating. I ain't even giving us food yet. What's wrong with that dog? That dog had learned to associate previously neutral stimuli, like footsteps, with the presentation of food, such that the previously neutral stimulus of footsteps came to evoke a physiological response, meaning it made salivation occur, which was originally evoked by another stimulus, which was the food itself, the meat powder. Interestingly, you got to salivate, right? Salivation provides lubrication for mastication. I already told you all a bunch of masticators, right? Everybody got to have a lubrication or you choke to death on your food. So it turns out that salivating before food arrives, from a functionalist point of view, is actually helpful. If you ever go see the Bay Mountain Wolves, right, and they feed them those dead deer they catch off the highway, right? They scoop them up, take it to Bay's Mountain if you see a roadkill deer. They'll throw it in the freezer. They have pack behavior, right? When you're in the wild, what? You better eat and eat fast, yep. So if there's anything in the environment that predicts food is coming, if you can start salivating quicker, that one bite you get before the other ones come and bump you out of the way might be the difference between survival and non-survival over time. So there's this adaptive mechanism happening where this dog is learning, and we don't think the dog is sitting there with higher consciousness going, you know what? Every time that guy comes in, he's bringing food. Next time he comes in, I think I'm going to salivate. Right? He doesn't think like that, and we don't either. But we do the same kinds of stuff. And also, interestingly enough, Pavlov didn't work with bells. His other people in his lab work with bells. The unconditioned stimulus is unlearned. You could say unconditioned equals unlearned. If that helps you to understand this process, you'll need to know these terms for your test because you'll need to break it down. Unconditioned stimulus evokes unlearned and unconditioned response. So in our Pavlov dog scenario, the food is an unconditioned stimulus. You don't have to learn to slobber the food. And what follows is the response. The response is salivation. You don't have to learn that. So Pavlov figured there are certain inborn, unlearned reflexes that we have as species. If I make a bam, real loud noise, people will jump. You don't have to learn to do that. It's inborn. It's universal. It's shared by everybody in the species. Likewise, when you smell food, you don't have to think about salivation. It just happens. So you have an unconditioned or unlearned stimulus that produces an unconditioned response. That's pretty straightforward. That we had to begin with. But now, there's some previously neutral stimulus. Footsteps was previously neutral. If you ring a bell, that's previously neutral. Right? A dog don't give a damn about a bell. You ring the bell, what's the dog going to do? Salivate the first time? No. It's previously neutral. He'll just look at you with that quizzical look, like, what's that? Yeah, they turn their head back and forth when they don't know what it means. Doesn't mean salivate, though. So with regard to salivation, ringing a bell or footsteps is a previously neutral stimulus. But it comes to have an association. The association then becomes strong enough that the conditioned stimulus itself provokes the response. It's eliciting the response. So that the conditioned stimulus is now pulling forth from the animal, us included, a response that it did not used to do because it's been associated with an unconditioned stimulus. And now we just change the name. It's the same response. In this case, it's still slobbering. It's still salivation. But because it's in response to the conditioned stimulus, we relabel it. Right? When it's salivation to food, food's unconditioned stimulus, and the salivation is an unconditioned response. But if you salivate to a bell ringing, well, now the salivation's in response to something that was previously neutral. Same response, but for a different reason, so it's relabeled as conditioned response. So, as I just implied, classically conditioned responses are elicited, drawn forth from the animal by the unconditioned stimulus, and eventually the conditioned stimulus has been paired with it. That's going to be an important distinction when we start talking about operant conditioning. Classical conditioning has to do largely with physiological processes that are pulled from us. You've had that moment where you were driving and you saw the blue lights come on and you had that little butterfly sense in your stomach, yes? Whew. And what'd you do also? Didn't you hit the brake rather reflexively? That physiological thing that's happening that makes you feel the butterflies is adrenaline, and that's classically conditioned. The trying to hit the brake is a behavior you could have voluntarily controlled. The first one you couldn't. The second one you could, but it happens so automatically that you don't perceive that you could. That would be operantly conditioned behavior. When blue lights came on when you were a baby, did you start having butterflies in your stomach and start throwing your foot around? Nope, you learn to do that through what? Association. What kinds of association? Well, we're really talking about contingencies here. If-then statements. Dependencies between events. And sometimes we perceive events to be related that aren't actually related. But if you believe that they are, they can have a very powerful effect. In fact, that's how you get superstitious behavior. Through erroneous contingencies. The dependency between an event can be stimulus contingent or response contingent, the latter being operant in nature, mostly. So in other words, i.e., if-then statements. If the light turns red, I should stop, all right? Why? Because if I don't, I could cause a crash or get pulled over. Right? So I start learning these relationships. And I don't have to experience them directly to learn them well. I probably had that experience early on in driving because throughout your entire learning history, you watch parents drive and potentially get pulled over. You watch people on TV get pulled over by blue lights and bad things happen, such that you start associating those. That's observational learning. So what we see is overlap between these types of learning, so I'm trying to be careful to keep each thing in its order so that you can see the differences and the similarities, because they're important. Now here's a technical drawing. I hope you appreciate the difficulty of this. Unconditioned stimulus. You need to know UCR, UCS, CSCR. Food. That's represented by the little brown balls up there. Dog salivates. Big old tongue hanging out, dribbling with slobber. That's the normal thing. That's unlearned. It's unconditioned, right? Unconditioned stimulus, unconditioned response. Different trial, meaning a different time. Ring a bell. Dog may look at you funny, but dog doesn't salivate. Now, Order matters. The bell precedes the food. There's different variations on conditioning, but the most effective is when the previously neutral stimulus almost immediately precedes the actual unconditioned stimulus. So I ring the bell, give the food, dog salivates, not to the bell, but to the food, right? Ring the bell, give food, ring the bell, give food, ring the bell, give food, ring the bell, give food. There's an association building such that eventually I'll be able to ring the bell and the dog will salivate without the food. Now I've got a little bit of a relabeling. This previously neutral thing is now our conditioned stimulus because it produces the response that food used to produce and still does. Now I've got the same behavior but in conjunction with this new conditioned stimulus, so I relabel it. Is everybody on the same page at this point? Any questions at this point? All righty. It gets a little more complicated.